Good morning, students. Continuation of the same chapter, complex numbers. Here, I'm going to write the operation on complex numbers. You know that the first operation is addition. Let Z1 is equal to A plus IB and Z2 is equal to, here you can write A1 plus IB1 and here A2 plus IB2. Then our aim is to find Z1 plus Z2. Z1 plus Z2 means add the real part separately and add the imaginary part separately. Listen, that is A1 plus A2 within bracket plus I into B1 plus B2. That is addition. Write one example. Z1 is equal to 8 plus 4i and Z2 is equal to 5 plus 6i. What is your Z1 plus Z2? 8 plus 5, 13 plus 4 plus 6, 10i. Very simple chapter. Z1 plus Z2 means A plus IB into A plus B plus I into C plus D4. Now, how to subtract? Suppose the operation is subtraction. What is Z1 minus Z2? What is your Z1? A1 minus A2. Subtract the real part. Plus I into B1 minus B2. Listen. Now, write one example. Z1 is equal to 4 plus 5i and Z2 is equal to 2 plus 4i. What is Z1 minus Z2? What's the answer? 4 minus 2. What is 4 minus 2? 2 plus 5 minus 4, 1. Or 2 plus I. Listen, that is subtraction. Now, next one is write the following questions in the form A plus IB. Write the following questions in the form A plus IB. Question is 1 by 1 plus I. 1 by 1 plus I. Look here. If the denominator contains a complex number, take the conjugate of the denominator. Then multiply and divide. If, what's the condition? If, not the problems, if the denominator contains a complex number or in the complex form, take the conjugate of the denominator, multiply and divide. Then repeat the question. Here we know that the question is Z. Z represents complex number. 1 by 1 plus I into. What's the conjugate of 1 plus I? 1 minus I. By 1 minus I. Multiply and divide. You know that. What is 1 into 1 minus I? That is 1 minus I. Now, the denominator is of the form A plus IB into A minus IB. Say, what is A plus IB into A minus IB? That is A square plus B square. Understand? What is your A? 1, 1. A square means 1 plus. B means, B is the coefficient of I. Look here. B is the coefficient of I. That is 1 plus 1. What is 1 plus 1? 2. Therefore, what is the final answer? 1 minus I by 2. Actually, you can split this as 1 by 2 minus I by 2. This is of the form A plus IB. Listen, here 1 minus I by 2 we can write 1 by 2 minus I by 2. That is A plus IB. What is our question? Write this question in the form a plus ib. Then write another question. Z is equal to Z is equal to. Z is equal to 2 plus 3i by 4 minus 3i. This is also a complex number. Then here also the denominator contains a complex number. Therefore, what's the procedure? Multiply and divide by the conjugate of the denominator. Then write the question. 2 plus 3i by 4 minus 3i into 4 plus 3i by 4 plus 3i. Agree? Now, the numerator usual multiplication. Listen. 2 into 4, 8. 2 into 3i plus 6i plus 4 3s are 12i plus 3i into 3i. Understand? The last multiplication is 3i into 3i. What is 3 into 3? 9. I into I square. Can you say what is I square? In this chapter, I square means minus 1. Therefore, minus 9. The whole by the denominator is always of the form a plus b ib into a minus ib is a square plus b square. That is 4 4s are 16 plus 3 3s are 9. Now add the real part separately and imaginary part separately. 8 minus 9, what is that? Minus 1 plus 12i plus 6i, 18i by 16 plus 9 is 20. Now, what to do? Separate. Separate the real part and separate the imaginary part. Minus 1 by 25 plus 18 by 25. Minus 1 by 25 plus 18 by 25. Listen, here we write the question in which form? Of the form a plus ib. One more question. Z is equal to 1 minus I by 1 plus I. Say the answer. 1 minus I by 1 plus I into 1 minus I by 1 minus I. All the questions same procedure. Take the conjugate of the denominator, then multiply and divide. What is 1 minus I into 1 minus I? You know that 1 minus I the whole square. A into A is A square. Or direct multiplication. Anyway, 1 plus 1, that is 2. Expand the numerator. A square plus B square minus 2i by 2. What is 1? I square means minus 1 minus 2i by 2. 1 minus 1 cancel. Minus 2i by 2. 2 cancel. Minus I. Answer is minus I. How can you write minus I? I 0 minus I. When you write a complex number, here the real part is 0. Therefore 0 minus I. Understand? Write the same question and the question changes to 1 minus. Listen. The next question. The question changes to 1 minus I by 1 plus I the whole cube. Suppose the question is this. The first step is same up to minus I. That means you find the answer for this base. Base answer is minus I. Therefore, the last step is minus I the whole cube. minus I the whole cube. Now you are the 11th standard students. Understand? Therefore, write this minus I, then the answer changes to minus I, then what is minus I the whole cube? Minus whole cube means minus into I cube. How can you write I cube? Listen here, I cube means minus into I square into I. Therefore, minus into I. Minus into minus plus plus into I. The final answer is I. Understand? If it is square, you write minus I the whole square. If it is raised to 4, first you simplify the base. Then write the final answer in the form of A plus IB. Next, most of the questions are same type. Evaluate. One more question. Evaluate. Heading multiplicative inverse. Right? Multiplicative inverse. Z inverse is equal to Z bar by mod Z square. Multiplicative inverse, very important. Multiplicative inverse means Z bar. Can you say what is Z bar? Conjugate. Then what is mod Z? We know that mod Z means A square plus root of A square plus B square. The whole square. That means only A square plus B square. Let Z is equal to A plus IB. Then how can you write multiplicative inverse Z inverse? Z bar means A minus IB by mod Z square means A square plus B square. A minus IB by A square plus B square. Write one question. Find the multiplicative inverse of Z equal to 3 plus 4i. 3 plus 4. Then what is the answer? Z inverse, Z minus 1, Z multiplicative inverse. Take the conjugate of the question. 3 minus 4i by A square plus B square means 3 square plus 4 square. 3 minus 4i by, we know that 3 square plus 4 square is 25. Now, separate 3 by 25 minus 4 by 25. I is the final answer. One more thing, this here you can use the calculator. Okay.